Hello students, myself Dr. B. Sridhar, Professor, Department of ECE, MLR Institute of Technology, Hyderabad. Now we are going to discuss about total internal reflection. Before that, we will see some content. What is diffraction and reflection? Next, refractive index, critical angle and total internal reflection. Because to achieve the optical fiber communication, so these are the basic things are required to discuss. Fine. First, what is reflection and refraction? Generally we know that, so every object has the property of giving reflection. Okay, some object may have the property refractions also. So now reflection is nothing but a light you can pass. Okay, now you see about reflection and refraction. What is reflection? The reflection is nothing but the act of light reflecting back when it hits a medium on a plane. We can call it a reflection. Suppose let us consider, so this is the incident ray. So this is one medium, this is medium 1, I can say some medium 1 and this is medium 2. So here I just draw the normal line. So whatever the light pass through on medium, so immediately it can be reflected back. That's why we can call the light reflecting back its own medium is called reflection. Now coming to the refraction. The refraction is the one, so which can able to penetrate, the wave can able to penetrate into one medium to another medium. This is nothing but the refraction. So same case, see here I draw a normal line. So this is medium 1 and medium 2. So this is medium 1 and medium 2, assume. Okay, now I am sending a light. So this light, it can be penetrate and it will be reflected back. It's refracted back. It's nothing but a refracted ray. Okay. So now this object has a property to penetrate the ray, or it can accept the ray. We can call it a refraction. So if you see this waveform, see here this is the incident ray. So now here the refractive index is n1 and this refractive index is n2. Okay. Now it can be incident ray can be hit the target and it can be reflected back to the own plane, own medium. We can call it is a reflection. Or a ray can be accept, it can transfer from one medium to another medium. We call it a refraction. Okay. So here this angle of incidence and angle of reflection. So this is the angle of incidence. This is the angle of reflection. Here generally you can write theta I and this is nothing but the theta R. Okay. So which is calculated based on the normal line only. This is reflection and refraction. That is incident angle and reflection angle. Fine. Now let us come to the another important parameter in optical fiber communication is refractive index. So generally we know that the core refractive index is always greater than cladding refractive index. Now you can see one example. So here I can take two medium, one is air medium or vacuum medium, or next one is glass medium. Now the incident ray is passing over here. So here just I draw the normal line here. Okay, then line can be passing here, the ray can be allowed. Here my glass is able to receive the light signal. Here the refraction process is going on. Not reflection, refraction. Okay, as I said earlier, if the light reflected back to the own medium, it is reflection. Now if you see this one, here the light ray is enter in one medium to another medium. A simple word, here the light, it can travel from one medium to another medium. Okay, so now see this is nothing but the incident angle theta I, this is nothing but the refracted angle theta R. Okay. Now see, here we know that the speed of the light is 3 into 10 power 8 meter per second. In air medium, the speed of the light is 3 into 10 power 8 meter per second, while in glass medium, now let us assume the speed of light may be decreased. Okay, generally the water or any glass medium, the speed of the light may be decreased. In air, here we know that constantly the speed of the light is 3 into 10 power 8. Okay, so when the light ray penetrate from air to another medium, whether it may be a glass medium or water, may be case, the light speed may be vary, surely it will be decrease. Okay, now because of these two value, if you see this one here, the air medium I can say it's a rarer medium, the glass medium I can say it's a denser medium. See, it is a rarer medium, here the glass I can say it is a denser medium. Now if you observe this one, the speed of the light is 3 into 10 power 8, so it is high, maximum speed of the light is 3 into 10 power 8. Okay, it means that there is no resistivity, no resistance, no less resistance. Okay, but if you consider in glass, see 2 into 10 power 8, so which consider more resistivity. So because when a light passes through some denser medium, surely because of the resistance the light cannot able to pass speedily. So that is why the speed may be decrease because of the more resistance in the denser medium. But in air not like that. In air, here there is no resistance, very less number of resistance, I can say it is a less resistance. Okay. So now because of these two values, so we can calculate the refractive index. If you see the refractive index is nothing but simply one word, here just it measures the optical density of the medium. What is the optical density of the medium? Here simply I can say a speed of the light in a vacuum or air divided by a speed of the light in a glass, or otherwise you can say a speed of the light in one medium by the speed of the light in another medium. Okay. So now let us take the same example here. So the speed of the light in air medium is 3 into 10 power 8, the speed of the light in glass medium is 2 into 10 power 8. Okay. Now if you see here, if you calculate this one, here you are getting 1.5, is nothing but the optical density of a glass, optical density of the glass. So what it means? It means that the speed of the light is 1.5 times slower in a glass than a vacuum. So that is why refractive index is one of the important parameter in optical fiber communication. The speed of the light is 1.5 times slower. So because the speed of the light in glass is only 2 into 10 power 8, some assumption value, speed of the light in air is 3 into 10 power 8, so the numerator value is higher, then that is why the density of the glass is just only 1.5. Okay, it indicates the 1.5 times slower in a glass than a vacuum. So that is why in optical fiber communication always we should maintain the refractive index of the core should be greater than the refractive index of the cladding. If you see, it's a core refractive index is N1, cladding refractive index is N2, so always we should maintain the high refractive index of the core, because we are propagating the waveform in a air medium. Okay, so inside the core, so full of air only, vacuum, hollow space. Okay, so the speed of light is high. Now another important concept in optical fiber communication is critical angle. So let us consider a two medium, here a air medium, next one is the water medium, the two medium I am taking. Now here when a light passes from water medium to air medium, assume here we are passing the light from water to air. Okay, here also same thing, here the normal line is there. So this theta I is nothing but, here the theta I is nothing but the incident angle, and theta R is nothing but the reflected angle, sorry, refracted angle, refracted ray. Okay, so let us consider a critical angle. It's one of the important concept in optical fiber communication. Here you can take, let us consider a critical angle. Here you can take the two medium, one is the water, another one is a air medium. Now when a light ray passes from water to air medium. Okay, so here the incident angle is theta I and the refracted angle is theta R. Now what I am doing, I keep on increase the angle of incidence. I keep on increase the angle of incidence. At one stage the refracted ray is lies parallel to the medium, water medium. Okay, so this angle is nothing but a critical angle. Here I can keep on increase the angle of incidence at one stage. So what will happen, this refracted ray is comes parallel to the water medium. Okay, so it means that, so it gives 90 degree, it gives that 90 degree angle. Okay, now you can consider Snell's law. Here n1 sin theta I is nothing but the refractive index of the water medium, and the theta I is nothing but the angle of incidence, and n2 is nothing but the refractive index of the air, and sin theta R is nothing but the angle of refraction. Okay, so this is a normal condition, this is nothing but the Snell's law. This is Snell's law. Okay, now as I said earlier, just we can increase the angle of incidence at one stage, so it become exactly parallel to the water medium, it exactly lies on the plane. Okay, so it means that here the refractive angle is 90 degree. Now just I can substitute theta R is equal to 90 degree, then I can get n1 sin theta I is equal to n2. So here sin theta C is equal to n2 by n1. This angle, the angle of incidence in a denser medium for which the angle of refraction is 90 degree, that angle is said to be the critical angle. Now I come to the topic total internal reflection. As we know, here the light ray passes from one medium to another medium. Here the incident ray and the refracted ray. So now the light ray passes from water to air medium. Here incident and the refracted. So you can call say theta I and theta R. Now just now I explained about the critical angle. If I keep on increasing the angle of incidence, then what will happen, exactly this ray comes parallel to the plane. Okay, now again I keep on increasing the angle of incidence. So what will happen, whatever the angle of incidence, it totally reflected back to the same medium. This concept is called a total internal reflection. A total internal reflection. In this, here the main important concept is the angle of incidence is greater than a critical angle. If it satisfies this condition, then whatever the ray we are passing from one medium, it totally reflected back to the same medium. Okay, so this concept is called a total internal reflection. So it satisfies this condition that theta I should be greater than theta C. That is, when an angle of incidence is greater than a critical angle, it means the incident angle is reflected back to the medium. This is called total internal reflection. This is a very important concept in optical fiber communication, because here whatever the signal we are propagating in the optical core, okay, so it should obey the total internal reflection properties. So the signal it won't refracted, we should achieve internal reflection. Fine. Now I come to the conclusion. Just we discuss about what is refraction and reflection. The refraction is nothing but when an incident ray is enter from one medium to another medium is nothing but the refraction. While reflection, whatever the incident ray is again get it back, it means that so it won't passes to one medium to another medium is nothing but the reflection. Now refractive index. So the refractive index may be calculated by using the formula, the speed of the light in one medium by the speed of the light in another medium. Okay, so from this you can calculate the refractive index. Next we can discuss about the critical angle. The critical angle is the one, the reflector ray, so the refractor ray which lies parallel, which lies on the medium, we call it a critical angle. Finally, we discuss about the total interreflection. So total interreflection, it can satisfy the condition here the angle of incidence should be greater than the critical angle. It is very important concept in optical fiber communication. Thank you.